Hello, my name is Mr. Wyrick. I'm here to talk to you about lesson 10.2. This one will be about angles and arcs. We're starting to move into types of measurements, things that you can find out from circles and things that you would do with circles. The first thing is the central angle. A central angle is an angle formed by two radii. So you have a radius and another radius, and then you have this right here, and this is a central angle. You have the other central angle coming around this side, so they add up to 360. You'll see this used a lot in pie charts. In pie charts, they do percentages out of the whole, so they multiply that by 360, they make the angle correct, and so we have a whole bunch of different central angles there, and they always add up to 360 degrees. The minor arc is this one here, the smaller one. The major arc would be the larger one around the outside. Okay, the central angle and the arc are connected. If this is, for instance, an 80-degree angle here, then this arc length is 80. So out of 360, 80 would leave us 280. So this back one's 280, and the major arc is 280. The arc length is equal to that central angle measure. If you have a semicircle, that's where it is cut in half. That's what semi means. If you're in Miss Payne, Miss Kiefer's class, studying your Greek and Latin roots, that semi is half. So you have half your circle, it's half the measure. The angle's 180 degrees, the arc is 180. Congruent arcs, you have to be careful on this one. It's obviously the same measure, but it can't be like a smaller angle in a bigger circle. They either have to be from the same circle, and there's two 30-degree angles, so there's two 30 arcs, or congruent circles. Like we know the circles are congruent. They both have a 30-degree angle, so we have congruent arcs from those two. When we were talking about adjacent arcs, ones that you can add together, subtract, whatever, if we're talking about the adjacent ones, they are next to each other. They have one point in common. And you have to remember, we're not talking about the angle where they would share the center. So we've got this central angle, we've got this central angle over here. This point would be the one that these two arcs share. So we have those adjacent arcs, they're next to each other here. And they have to add together to make this entire angle here. The arc length in units. If we have the circumference and it's so many centimeters and we know the angles, then we go back to like what we have up here. So if my circumference of this circle was, for instance, 50 centimeters, then I would look up here and I'd say, okay, 80 out of 360 would be the same as 8 out of 36, which would be 4 out of 18, which would be 2 out of 9. So I'd multiply 2 out of 9 by this. It'd be 100 divided by 9. So 11.1 repeating centimeters would be the length of this arc if the circumference was 50. You can do a lot of calculation with that, and that's probably where the majority of the true math, not just identifying, classifying, but doing some true calculation, where that's going to come from on today's lesson. The next thing that's going to come up is radians. Radians are expressed using theta. Okay, this is our friend theta. It looks like a 0 with a line through it. Whenever we're going to talk about radians, we always say what is the theta of this, and then you know to measure in radians. Radians are relative to the radius of the circle. So if we're going to measure the arc, if we have a circle like this, the whole circle is 2 pi radians, because we would take the radius of that circle and multiply by 2 pi to go all the way around. So half the circle would just be pi. A fourth of that circle would be pi over 2 radians. And from there, you just kind of divide it out. Okay, you can set up the fraction and say, okay, I know the whole circle is 2 pi. This is 30 degrees. That's 30 out of 360, which would be 1 out of 12. So we would divide this by 12. So that would be pi over 6 would be this arc length in radians if this is a 30-degree angle. Okay, it can be a little confusing. I would not try to use the calculator for this, like switch it back over into radians and use that, because you get a decimal answer, and it's much easier to write your answer in terms of pi. It's much easier for everyone to check your answer for accuracy if it's written in terms of pi. If you have questions about any of this, especially the radians thing, make sure you come in tutorials, bring those up during class so we can discuss it as a class. Someone else might have the same question as you, but just be too shy to say anything about it. I'd like you to do numbers 14 through 54 on the assignment for today. If you have questions, this should be the day that I am gone for a tennis tournament. So make sure to check in with me when I come back to class, and we'll see you then.